Finding the shortest distance between two straight lines using vector algebra is the objective of this video. Let's consider line 1, line 2 and line 3 as you can see in this image here. Now we can see that line L1 and L2 are in one plane. So line L1 and L2 are called coplanar because they are in the same plane. However, line L1, line L3 don't meet each other, they don't intersect, and they are also in different planes and they are not parallel to each other. So these lines L1 and L2 are called skew lines. Now if any two lines are either parallel or intersecting, they are called coplanar. Let's see how to find the shortest distance between two lines. First, let's consider the case of two parallel lines. Okay, so here we are given two parallel lines, which is r is equal to vector A plus SB vector and vector r is equal to C vector plus TB vector. Now the shortest distance according to this theorem says that D is equal to magnitude of C minus A cross product with vector B divided by the magnitude of B, where B magnitude should not be equal to 0. Okay, so let's consider the line L1 and the line L2, and let's also mark 2 points A and B on line L1 and L2, and let A vector be the position vector for OA and C vector be the position vector of OB. And so vector AB will be defined as C minus A vector. We will also draw a vector B which is parallel to both line L1 and L2. Since L1 and L2 are parallel, vector B can be parallel to both these lines. So let's put these in words here. So the given two parallel lines are denoted by L1 and L2 respectively. Let A and B be the points on L1 and L2. So defining A and B as points on L1 and L2 whose position vectors are A and C. So we have that here. Great. So next the two given lines are parallel to vector B. Then let AD be a perpendicular to the two given lines. So we are drawing AD perpendicular to both L1 and L2. It's a bit congested, this drawing image here, but it's very clear. AD is perpendicular to both A or L1 and L2. So if theta is the acute angle between vector AB and vector B, so vector AB is here and vector B is here. So let theta be the acute angle between these two vectors. So if theta is the acute angle between these two vectors, then it will be also the angle between BD, the line L2, and AB, because B is parallel to L2. So using our cross product magnitude formula, we can define sine theta as magnitude of AB vector cross product with B vector divided by AB vector magnitude into B vector. Let me show you how we can get that. So the cross product of AB vector into B vector, the magnitude is equal to AB vector magnitude into vector B magnitude into sine theta, where theta is the angle between AB and B. So rearranging this, you can say sine theta is equal to, bringing this to the denominator on the other side, AB vector cross product with B vector magnitude divided by magnitude of AB into magnitude of vector B. So we're using that here. and we are substituting the values of AB, which is nothing but C minus A vector, into this formula. So let's leave this aside on one side and let's look at this triangle A, B and D. Now, since AD is perpendicular to both L1 and L2, you can call this as a right angle triangle, ABD, right angle triangle. And if this angle is theta here, then our sine theta from this would be opposite side, which is D, divided by the hypotenuse, which is AB vector magnitude. So let's put that down here. So from the right angle triangle ABD, sine theta is equal to D by AB, which is AB is nothing but magnitude of AB. Again, substituting the value of magnitude of AB as C minus A vector, we get this. Now you can see that this sine theta here and sine theta here, so we can equate these two lines, or say these two equations. So when we equate these two, what happens is C minus A and C minus A is common to both. We can eliminate it. So vector D, or D will become equal to this numerator here divided by the magnitude of B. So that is our D. So D is the shortest distance between these two parallel lines where B vector cannot be equal to 0 as its magnitude. Next, let's find the shortest distance between two skew lines. So according to the theorem, it says that the shortest between the two skew lines, which is given by R is equal to A plus SB vector plus R is equal to C vector plus TD vector, is given by sigma is equal to magnitude of C minus A dot product with B cross product with D divided by the magnitude of B cross product with D, where the denominator is not equal to 0. So let's consider L1 and L2 to be our two skew lines. So when I say skew lines, they don't intersect and they are not parallel either. Great. Next, let's assign 2 points A and C. A on L1 and C on L2. And let's define vector A for the position as a position vector with the point A and C as a position vector for the point C. So L1 denotes the line 1 and L2 denotes the line 2 as I put it in words here. Similarly, A and C are the points on L1 and L2 with position vectors A and C respectively. Great. Next, from the given equation of skew lines, we observe that L1 is parallel to vector B, or L1 is parallel to vector B because it's given here. A plus SB vector. So B vector is parallel to this line L1. Similarly, D is parallel to the line 2. So L2 is parallel to vector D. So if we take the cross product of B and D, then it's perpendicular to the lines L1 and L2. Cross product of B and D will be perpendicular to the lines L1 and L2. Great. So next, let's draw a line segment SD. So let SD be the line segment perpendicular to both L1 and L2. So SD is perpendicular to both L1 and L2. Then the vector SD is perpendicular to the vectors B and D, and therefore it's parallel to the vector which is B cross product with D. I think that's simple. So let's proceed and let's define a unit vector for SD. So the unit vector for SD can be defined as the cross product of B with D vector divided by its magnitude. All right, I'm sure that you're familiar with finding the unit vector. for any given vector. So that's the formula. Next, the shortest distance SD can be defined as the absolute value of the projection of vector AC on vector SD. So this is a vector AC and this is vector SD. So AC makes a projection on SD. Then the shortest distance, which SD vector, which will be the magnitude of SD, it will be the absolute value of AC's projection on SD. So further we can define that shortest distance as sigma. Okay, so we have sigma here. So sigma is the magnitude of SD and it's defined as AC vector dot product with the unit vector of SD and its magnitude. Alright, so replacing the vector AC as C minus A vector, then we have the shortest distance as the magnitude of C minus A vector dot product with cross product of B vector with D vector divided by the magnitude of B vector cross product with D vector. We can further rewrite the formula in this form, and where the denominator cannot be equal to 0. So this is the formula that we would use if you are given two skew lines which are not parallel and which do not intersect with each other.
Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.